closest galactic neighbor, the Andromeda Galaxy, is 2.5 million light years away from Earth. If we take our fastest modern spacecraft traveling at 28,000 kilometers per hour, it would take us 94.5 billion years just to reach it. Even if we could somehow travel at the ultimate speed limit, the speed of light, it would still take 2.5 million years. So, are we permanently trapped inside the Milky Way? Imagine if there was a cosmic shortcut, a bridge through the fabric of space itself that lets us jump millions of light years in just seconds. To understand how a shortcut in space is even possible, we have to go back to 1915 and Albert Einstein's theory of general relativity. Einstein showed us that space and time aren't separate, static backgrounds. They form a single 4D fabric called space-time. Think of space-time like a stretched elastic sheet. When you place heavy objects like stars or planets on it, the sheet bends. That curvature is what we perceive as gravity. Now, Einstein's equations, the Einstein field equations, were so complex that even he couldn't fully solve them all. In 1916, physicist Carl Schwarzschild found an exact solution, showing what happens when mass becomes infinitely dense. Space-time bends so severely that it forms a point of infinite density, a black hole. But black holes weren't the only extreme solution hidden inside Einstein's math. So if wormholes exist, how do we enter one? Mathematically, to open a wormhole, you need an extreme gravitational force, like a black hole as an entrance. But that creates a huge problem. Black holes pull everything in and destroy it. If you enter, how do you get out the other side? You would need an exit point that does the exact opposite of a black hole, something that continuously repels matter and light. Physicists call this theoretical object a white hole. While a black hole has an event horizon where nothing can escape, a white hole has an event horizon where nothing can enter. It only ejects radiation and energy. Some scientists hypothesize that when black holes die or evaporate via Hawking radiation, all the trapped information inside might be expelled through a white hole. However, white holes remain purely theoretical today because they seem to challenge the second law of thermodynamics regarding entropy. Even if natural wormholes exist, keeping one open for human travel is another challenge. Gravity would instantly crush the tunnel shut unless it's stabilized by something called exotic matter. Matter with negative mass and repulsive gravity. Are wormholes impossible then? Not entirely. In 2015, scientists actually built a magnetic wormhole in a lab using superconducting materials, proving that field geometries can be routed through hidden shortcuts. And even without wormholes, physicists have proposed alternative ideas like the Alcubierre warp drive, which contracts space in front of a ship and expands space behind it to travel faster than light without violating relativity. While science fiction often becomes a science fact of tomorrow, black holes were considered purely imaginary 100 years ago, and today we have actual photos of them. Well, what's your take on wormholes? Could they one day change the way we explore the universe? Let me know in the comments below. Hit that like button if you enjoyed this explainer, and don't forget to subscribe for more deep space breakdowns. See you in the next video.